Hi and welcome to another cosine rule video. This time we are going to find the angle in a non-right angled triangle using the cosine rule. Just a reminder that the cosine rule is a squared is equal to b squared plus c squared minus 2bc cos a, and this would be how we might label up our triangle, with a big letter at the vertices of the triangle and then a small letter on the side opposite the particular vertex. We have a triangle here and we are being asked to find this angle. So if we're being asked to find that angle, I would usually call that vertex where the angle is A. And then it wouldn't really matter which way round you did the other sides, so just go round in a clockwise direction, A, B and C, and then label up my sides. So opposite the large A is going to be little a here. Opposite, I'm using a different colour because of this included angle thing. C is here, little c, and opposite B here is little b. Now, there are two ways of solving this particular problem using the cosine rule. You can either use the cosine rule in this form and use substitution and go through and find the answer, or you can use a rearranged form of the cosine rule. And I'm going to do both here, so it's entirely up to you which one you choose to do. I prefer to use this and use substitution, but I know many students prefer to learn another formula. So we're going to use on this side a squared is equal to b squared plus c squared minus 2bc cos a, and I'm going to substitute in the values that I have already been given from this diagram. So a is 3 squared is equal to 2.5 squared plus 2 squared. Take away 2 times 2.5 times 2 times cos x, and close my bracket. Once I've written that down, that is where I would get my first mark in an exam, because I have correctly substituted the values that I've been given into the formula that I'm going to use. Then you can use your calculator to do bits and pieces. I'm going to do every single stage. Some of you might, as you get more confident with it, take a few shortcuts, but I'm going to stick with showing every stage. So 3 squared is 9, and that is equal to 2.5 squared, which is 6.25, plus 2 squared, which is 4. Take away, and then 2 times 2.5 is 5, 5 times 2 is 10, so 10 lots of cos x. And remember, we are trying to find out x. Tidy this up. 9 is equal to 10.25, take away 10 lots of cos x. If I subtract 10.25 from both sides, I get minus 1.25 is equal to minus 10 cos x. At this point, because I have a minus sign on both sides, they will cancel each other out. And mathematically what you're doing is you're timesing by minus 1 or dividing by minus 1. But if you can't remember that, you just need to know that on both sides, if they're both negative, you can get rid of that negative sign, and it's mathematically correct. So we've got 1.25 is equal to 10 lots of cos x. Divide both sides by 10, and I would get 0.125 is equal to cos x. And then on my calculator, I need to find the inverse cos of 0.125. So I pressed Shift cos 0.125, and that would appear like this: cos to the minus 1, 0.125, and that's going to give me x. I'll just write a little note here. So this is Shift cos on your calculator, and that means that x ends up being 82.8 degrees. So that is how to do this problem if you are just doing a direct substitution. Now you can rearrange this formula, and if you rearrange this formula and you make cos A the subject, you would end up with cos A is equal to B squared plus C squared minus A squared all over 2BC. And then again you can do a straight substitution, so we would have cos A is equal to 2.5 squared plus 2 squared minus 3 squared all over 2 times 2.5 times 2. And again, do not work this out on the first run through of the formula, because the first mark is for correctly substituting the values in. So even though this is a pretty straightforward multiplication to do, you still need to write down in full before you do any calculation. All of this, if we put it into our calculator, would mean that cos A is equal to 0.125. And again, then we just need to do our shift cos 0.125, and that would give us cos to the minus 1 and tell us that the angle at A is 82.8 degrees. So exactly the same answer. It does seem, when you look at my workings, that it's a little less work to do this, but I think that you have to learn another formula, and I prefer just to remember the one formula and then substitute these values in. And remember, when I'm demonstrating it, I am going through every single step of it, so that's why it might appear to be more workings. Whereas here, the substitution comes in much more quickly, and you can just pop that in your calculator. So whichever way you decide to do it, here you only have to use one formula and do the substitution, and you eventually get to finding out what the cos of the angle is, and then you do shift cos. Here, if you've learnt this other formula, you have to do a substitution, and then you just do a shift cos at the end of it. Okay, thanks for watching.